Hi, in this set of videos, we're going to be talking about IPv6, starting with IPv6 address notation. For more information, you might be interested in my book on IPv6, the second edition is the latest, and a live lessons video series, both I've done for Cisco Press. So I think they're pretty good sources of information. So I hope if you are interested in IPv6, I hope you'll take a look at those. All right, let's get started. So IPv6 addresses are 128-bit addresses represented in hexadecimal. Excuse me. Remember, hex is one hex digit is 4 bits. Okay, so 8 16-bit segments, sometimes we call them hextets, not a formal term, can be represented between all zeros and all Fs. Remember, hexadecimal uses both 0 through 9 and A through F. Okay, so each of these 16-bit segments is 16 bits. Okay, and we separate those with colons. Okay. And this will make reading and subnetting IPv6 much easier than IPv4. Now, typically, you notice on some occasion I'll have capital letters instead of lowercase. The trend has been, it really doesn't matter, but the trend has been to move towards lowercase. So anyway, you should be consistent. I wasn't in this screen, but that's okay. All right. We have 2 rules for compressing how we write IPv6 addresses. Rule 1 is that we can omit leading zeros in any 16-bit segment. So find just where we have leading zeros, not trailing zeros, we can actually omit those zeros. Okay, I'm leaving the spaces just so it's easier to see. Okay. And I said only leading zeros, not trailing zeros, because if we allowed trailing zeros to be omitted, we wouldn't know what this was, right? It could be any one of those. Okay, but it's only leading zeros, so we know it's the first 2 zeros. All right. All right, so that's actually the first 8 bits in binary, 4 bits per hexadecimal digit. The second rule is the double colon. Okay, the second rule states that any single contiguous string of 1 or more 16-bit segments that consist of all zeros can be represented by a double colon. Okay, so we can take this contiguous string of 4 16-bit segments or hextets and just reduce that to with 1 double colon. So our first rule says, well, we can omit that leading zero and those leading zeros. So let's take a look. Can't touch those, right? Trailing zeros. So that would give us this. Notice that we're using the double colon instead of those 4 segments of all zeros. All right. Now, rule 2, the double colon, says only a single contiguous string of all 0 segments can be represented with a double colon. Okay, so if we take a look here, both of these would be correct. We could write it this way, where we use these 2 segments, these 2 hextets of all zeros, and represent it with a double colon. And then we would have to use the first rule of omitting leading zeros to reduce the size of the second hextet, second group of 2 hextets. We could do it this way. Okay, we could actually use the double colon on the second group and reduce the first group by just omitting the leading zeros. Okay, although it really doesn't matter and operating systems will take it either way, of course there's an RFC that states that which one should you use? Well, you should use whatever has the longest string of zeros. And if they're equal, then you should, then the first string of all zeros should be replaced using the double colon, but it really doesn't matter. Okay, this is known as the compressed format. Okay, using the double colon, can only use it once. This we cannot do. Why? Because we wouldn't know what this looked like. Okay, could be, too much, there's ambiguity in which how many zeros are in each group. Okay, so whoops, let me back up here. So we can only use it once. All right, so it's that easy, and you'll really get used to it, and you'll see the advantages of this once we get into looking more at IPv6 addresses, subnets, and subnetting. Makes it all really easy.